me up.
All right then.
Thank you.
Hello everyone, thank you for taking your time to meet with us today. I'm Roberto Esca Martinez, we are the USC Senior Design Team, and this is our preliminary design review. So first off, a little bit of background about us. We're going to be working with the MTU America plant over in Grantsville, South Carolina. Our sponsor is one Mr. Nathan Jones. Our faculty sponsor is Dr. Sang-Hee Wong. The team members themselves will introduce when they begin talking, and the project scope would be to transfer the DEF to a primary storage tank, transport the fluid to multiple day tanks located on the second floor of the R&D building, and to be able to monitor the DEF levels and automatically notify the operators for when levels get to a critically low level. To begin, we developed some needs for the project, which includes meeting OSHA safety requirements, being able to store enough DEF fluid at a time for logistic purposes, tie into current PLCs, be easily refillable, and require less manpower. With these needs, we were able to write up a mission statement which reads out as MTU needs a diesel exhaust fluid storage and transportation system that reduces risk, monitors current and accurate fuel levels, and is easily maintained. With our needs, we set some target goals and some minimum requirements, including being able to store at least a minimum of 3,000 gallons of DEF fluid at one time, requiring less than 2 people that are currently used for the current system, being easily refillable by the supplier's driver, and being able to notify the operators once levels reach about 25% in the active fuel storage tank.
So since we last presented to you, we've changed up our selected concept a little bit. We're going to be keeping the same method of manpower where we're bringing in the tractor trailer tank from Avid Oil. That's where the direct fuel, DEF fluid will be coming in. We're going to move the location of the storage tank from the basement to the outside of the R&D building on the west side per our conversation with Nathan Jones. This is going to be direct feed, as I said, from the tractor trailer. We're storing it in a bulk tank still. We're still using an ultrasonic sensor to monitor the fluid level, and we're using a double diaphragm pump to move the fluid from the storage tank to the DEF tank. So the nice thing about this concept is that it's more accessible and easier to maintain the pump. The ultrasonic sensor is something that's already used in the day tanks. It's much less expensive to buy the DEF in bulk. Instead of using the totes that y'all use now. It's going to require significantly less manpower as far as refueling. We just got to hook it up and unhook it. And then a bigger storage tank just means that you have less deliveries that you're going to have to make in the end. So the downside to this, though, is that an outside storage tank does mean that we're going to have a little bit additional cost. We've got to figure out how we're going to insulate the tank and to prevent it from freezing and protect it from sunlight. And then we're going to have a concrete pad to place the storage tank on, and we could potentially need a pump shelter if the pump cannot be placed inside. And then y'all had talk of expanding the R&D building, so this would have to be incorporated in the future. So, next one. And then y'all mentioned wanting a backup system, so this is just our basic idea for a backup system where our new system would be on the west side and that backup system's on the east side of the building. And you would have, these are the pipes here. This is just a general layout. So you would have a ball valve that would be just at the end of the day tank, at the end of this old system layout, which would be shut on a normal basis. And you would have a ball valve that would be open on a normal basis on the new system side. And so if anything were to happen, you'd close off the new system side, open up the old system side, and you'd hook up a carbo and you'd be good to go.
Hey, I'm Kristen. So after our conceptual design review, we were tasked with creating product architecture, and simply put, this is the arrangement of the functional elements into physical building blocks that we defined as clusters. And these clusters were formed by grouping the elements within the design that tied in closely together. While these clusters cannot act independently of each other, they do allow for easy maintenance and improvement without the need to modify the entire system. And by going through this process, our team was able to determine how much of the proposed design could be fitted with modular components with each cluster in the system. This will decrease implementation and maintenance costs and simplify any complex structures within the design. So here we have our schematic of the system with clustering. The solid arrows between the components represent the physical interactions within the system, and the dotted lines represent the electronic interactions. The clusters are arranged primarily upon function sharing and geometrical integration. So for example, supply DEF, safety containment, and direct feed, they all share a similar function of transferring the DEF into the storage tank. Over here, we have our incidental lines of interactions of the system. These are unintentional, but we need to account for them. So for example, the vibrations from the pump could cause inaccurate readings from the ultrasonic sensors for the fluid levels, as well as heat transfer from the pump to the fluid could cause compromisation of the insulation within the tank. Here's our geometric layout of the design. It shows the optimal place of each element according to the relationship of the interactions between the components. So for example, we place the ultrasonic sensor on top of the tank because that will give us the most accurate reading of the fluid levels, as well as the direct feed import or port on top of the tank because that allows for the easiest flow of the DEF into the storage tank, and that's one of the very common practices is to put it on top for most bulk storage tanks. And next, we're about to look at our illustrated CAD drawing.
Hey everyone, I'm Charles. This is our CAD drawing. It's got all the units. These are in inches, and this is based off of a 3,500 gallon tank. Other things you have, this is really just an overview of sort of like how the subsystems within the component, the entire system fit together. And here we have the pump, which is just dimensioned based off of the footprint it would have. On to the next one. This is the exploded view. It's got a little bit more detail so you can actually see how the components are fitting together. You can see there's a pretty large difference in some of the sizes of the components, so in later slides we'll see more close-up detailed views of the subsystems within this system, but overall you can see how the parts are put together within the entire system. Now next slide we're going to look into the subsystem of the refueling process. You have to start with a spill containment system on the far side there. That's for the hookup from the tractor trailer hose to help prevent any spills. Number two, here we have the shutoff valve, which is manually done just in case shutoff during the refueling system needs to be done. Part number three here is the check valve, so it can automatically shut off upon to reduce the chance of overfilling of the tank. Here at number four we have the vent that will release pressure within the tank. And at number five, this is the ultrasonic sensor that will be on the inside of the lid measuring the volume within the tank. Next slide, we have a detailed view of the pump system because the piping for the pump is a lot smaller. Again, number six is the pump. That's just based off of its footprint, those dimensions. And number seven, we have the shutoff valve, like she was mentioning before. So if there was needing to be maintenance or something for this new system, you could just shut this off and then turn on the valve for the old system to be in place. And the other parts are just different size pipings leading from the storage tank to the day tanks.
All right, so after we established a lot of the technical things that we've had to establish throughout this project, we came up with a few to-be determines up to this point. Those to-be determines are the actual tank location. We had a little bit of a discrepancy between whether it should be in the basement or outside because of a talk that we had with maintenance made it a little harder to put the tank inside. So now we're going with this outside tank idea. And The specific tank size will also have to be determined based on the location of the tank. And then we will also need to develop a very concrete bill of materials for you guys based on your vendor pricing that was, based on the vendors that were given to us. And we plan on establishing all these, we plan on resolving all these to be determined by the end of January of next year. Go ahead to the next slide. In this slide here, we have the estimated budget. Now, these prices, well, we took the elements, each of the components from the drawings before that were presented, and we came up with a couple of candidates for each of the components based on different vendors and different prices. And the ones that are highlighted in red were the ones that we actually planned on using. If you look at the bottom, it would be at the bottom right of this bill of materials. We have calculated a total based on all the materials that we've used. These ones in red have been totaled up. We calculated in a little bit of labor, and then we have also calculated in a little bit of extra price just in case in case we need to change a component or redesign something small. And we came up with a total of about $24,000 for this design project as our estimated budget. You can go on to the next slide. All right, so as far as wrapping up this project, in February we plan on doing an engineering analysis on the design that we've come up with. In March we plan on testing and refining the system that we've come up with based on the analytical engineering analysis that we've done. And then we will go on to completion in late April.